We want to look at what completing the square means. What does it mean to complete a square? So when you talk about complete, it means something is lacking. So something is incomplete and you want to complete it. And what are you completing? You want to complete the square. And you remember what a perfect square is. Now, supposing you have an expression, I have x squared plus 4x. So you have this as an expression. Then I want this to be equal to a square. I want to make it a perfect square. I want to write it in this form. I want it to be equal to x. You know that any number with index 2 is a perfect square. So I want to make it a perfect square. I want to write it as x plus something. I don't know that thing. Maybe I'll call it a. But I know that x plus a all raised to power 2. So that's what I want to do. I want to make this expression to be equal to this. But in order to achieve that, what I'm actually trying to do, in order to achieve this, you must make this to be a perfect square. So to make it now to look like this, I must add something here. There's something I must add in order to achieve that. And that thing I'm adding is to make it to be a square, is to complete the square, because something is lacking. So I want to complete that square. So that's what it means. So I must add something. And that thing I'm going to add, I don't know what it is. But what is important, I must add something in order to achieve that. So x squared plus 4x. So let that thing I'll add, supposing I call it c. I don't know, but let me call it c. I must add something. So I must add something in order to get this x plus another thing all squared. So in order to achieve that perfect square. So now to achieve that perfect square, I must add something. In this case, I'm adding c, which I don't know. So what do? I need to find that thing I must add. I must to find that c that will make this one to hold. So what do? I'll work on this. What is x plus a all squared? If you expand it, so let's continue. So let's say here x squared plus 4x plus c. Then if you expand here, x plus a all squared will give us x squared plus 2ax plus a squared. You agree with me? When you do that expansion, this is exactly what you are going to get. Now, it means that here is equals to this place. So now, two of them are equal. So what it means practically is that you observe what is happening. It means that for this equality to hold, it means that this x squared is equals to this x squared. This 4x is equals to 2ax. And finally, this c is equals to a squared. You see now. So I'm arriving at a point. Remember, I'm looking for that thing I must add to achieve a perfect square. And that thing is c. So from here now, you find out that my c I'm looking for is equals to a squared. That c I'm looking for is equals to a squared. But I still have a little problem. I don't know what a is. So I need to find a. So what it means that I'll keep this one by the side. For now, let's keep this one by the side. So let's leave it and go and find a. So here now, I'm looking at the part that has a. So you see that I have a here. So this is 2ax. And you agree with me that the middle are equal. Here is 4x should be equals to 2ax. Because two of them are equal. So from there I can get my a. So it means that here 4x is now equals to 2ax. What am I looking for? I'm looking for a. So in order to do that, you divide by 2x. That is the coefficient of a. Here you also divide by 2x. So what it means therefore is that my x will cancel this x. 2 will divide 4, which gives me 2. Here, this my 2 will divide this my 2. This my s will divide my s. What do I have left? I have a left. So I have that 2 is equals to a. So which is another way to write is that my a is equals to 2. So you see that my a is equals to 2. So I have gotten my a. Therefore, I can now get my a squared. So we now come back to this place. So we have gotten our a to be 2. So it means therefore now that c will be equals to 2 raised to power 2. So see, 2 raised to power 2 is the same thing as 2 times 2, which is 4. So that thing I must add is now equals to 4. So with this now I can write my equation. I have my A to be equals to 2, my C is equals to 4. So I can now substitute. So if I substitute here, I have my x squared plus my 4x, and my C is 4, so I have plus 4. Then here I have my x, and my A is what? 2. So this is a perfect square. So you see, I have gotten a perfect square. So I have made this part to be a perfect square. So what did I add? I added something. So I added 4 to make it a perfect square. So observation. What you observe is that it is actually this part that I want to add something to make it a perfect square. So what did I do? I divided this number. So I divided this 4 by 2, and I got 2. And after getting it now, I square it again. After squaring it, I now added it. So what I added was actually x squared plus 4x. So what I added actually was the half. I divided this 4 by 2 and squared it. And that's what I did. So there is a systematic way of getting that thing you must add. So in subsequent videos now, we look at more appropriate examples.